Dear all, this lecture will show in particular the availability of some tools which can help you to use some specific data which comes to a format that is quite common from climate models. In particular, we are concerned in this lecture about a data format, particularly it's called NetCDF. You might happen to find very often climate data from climate science available with this format. It's possible to integrate this data with several softwares available, and this will be just a brief overview of how you could use this data and which software can help you with this data format. NetCDF, it's used from several models, from global circulation models, also from downscale regional circulation models. So there are two different types, but very similar climate model. But what is also happening is that several agronomic data it's also made available with this format. The important thing is there are different NetCDF conventions, but there are then a common data format that it can be used to integrate this data and to use this data. It's important to understand that you might have data available which can have several dimensions. So if you're often using spatial data, you have dimensions on longitude and latitude usually. But with climate model and other type of modeling, you have other dimension very often. So you can have a height, so a different elevation you may have data. You can have also time dimensions, so you can have 3-4 dimensions with climate data. So it's important that you have a format that can structure the data and use the data, which is not just two-dimensional. And to handle this problem, there are libraries available and a wide range of application software which can use this NetCDF library to open and manipulate NetCDF files. These are here some common available software which have library. They can use this NetCDF format, which have a few different differences. So you can have a classical version of NetCDF, which is usually .nc, or you have more advanced NetCDF format, which comes with NC4 or NC5. In particular, it's important to understand the NetCDF file, which often you find as a .nc or NC4, have many different characteristics which are self-describing. You have a header which starts to give an information to the software and to people use it, describing what are the dimensions of the file. So you can have, for instance, how many the dimensions, how many pixels you have in the latitude, how many pixels you have in longitude, and how many time steps you have. So you, for instance, you have here with this particular file, you have one map, let's say, with 64 pixels in latitude, so going south to north, 128 in longitude, so it's going east to west, and then you have 12 time steps, so you have possibly here 12 different months for which you have 12 different raster, spatial distribution of rasters. Then you can have also in the same header other attributes that are usually important to understand what the file is and what are its attributes. And then you have different variables. So another important characteristic in NetCDF that you can store different variables. So you can have, for instance, in the same file, variables as minimum temperature, maximum temperature, average temperature, precipitation, And it's all structured in a hierarchical way where you can build on different variables, different time steps, and all this is integrated in one file. This is also happening in different, as mentioned before, in different data sets, which are often built in one unique file. For instance, agricultural model intercomparison project makes a lot of like agricultural data available as one unique file where you have all informations for different variables in one file. Different variables could be planting date, harvest date. For each crop, you have many different crops. You have different years. You have different characteristics if irrigated, rain-fed. And all of this comes in one unique file where you have heading information describing exactly what are all the different variables and dimensions. This is why it makes it so unique and useful, this format, and it's becoming more and more relevant. There are different platforms. One of these, it's very easy to use, and it's very advised if you have NetCDF, because it works really well with most, if not all, the NetCDF files. It's called Panoply. Here you have the links where you can download it. It's a Java written software, so it works on most platforms, most operating systems. It's free, and it's really easy to use it with different version NetCDF, and it pops up different characteristics of the NetCDF from which you can click on the 2D and 3D interface. So once you open it here, you will have a list of variables, and then you can click on each one of these and you can see, visualize the different variables. So you create maps, but also here in the options you have a possibility to create movie animations. And it's also possible to open and visualize this as array. It means you can see the different values, and then you can click here, zoom in, zoom out, and see different parts of the map. It's not really possible to extract tabular values. For doing this, it's also possible to use instead particular libraries installed in ArcGIS here, for instance, which is not a free software really, so but it has options in multi-dimension tools. You can create a make NetCDF raster layer, and then you can indicate a NetCDF. You can indicate at that point the variables, the longitude and latitude, the X and Y dimension, and then that creates output raster layer you can load in ArcGIS. It's also possible to load directly the information from NetCDF as a table, so you can basically create big tables with information for each coordinate. For different coordinate X and Y, you have columns for a variable, like for instance in this case monthly precipitation, and then for each coordinate X and Y in the raster, you have in the column the time series, the monthly time series of precipitation. Another software which is very handy to work with NetCDF is QuantumGIS. You have a particular library where you can add the raster layer as a NetCDF. It's a browser plugin that you can use to really scroll over different time steps, and there is also a very good tutorial to work with NetCDF. I left here the link to this tutorial for QuantumGIS to work with NetCDF. Technically speaking, here we end up in much more let's say articulated and technical software to handle NetCDF. I wouldn't really give you much details, but I really suggest you, if you really have an issue and you have to work with NetCDF, to use CDO, which is a software which works as a command line. So basically you can open it in DOS still if you have on Linux command lines, and then there are all a set of different commands that allows you to do different functions for manipulation and analysis of climate data, and it's very fast, and it has a very huge quantity of a library. Here I also indicate the reference web page where it's possible to download the libraries, and also there are information instruction on how to use the different commands. And also there are also other software there is I also say here it gets really complex. These are most advanced libraries in MATLAB, for instance, where you have toolbox for statistical analysis and data mining in meteorology, and it's possible to use different functions like that. Also allows you to do statistical downscaling, and also other function that helps you to elaborate and work with climate data. And also R, I don't know how many of you are, but I really suggest you to consider R in your understanding of R as a platform to do analysis of data in general. This could be ecological data, agroclimatological data, but also for climate data can be quite effective to use R. There are in particular some effective libraries to use R, like NetCDF and NetCDF Core, which are easy to implement, and it's easy to work in with NetCDF as array or matrix with the different commands available and GIS commands. So these are all different functions. I here added one last slide which I really would like to indicate some powerful options also that are available in Excel, because I often see that people download data as Excel files, and this is also possible, for instance, in different options from R, Climate CDO, and other software from NetCDF. It's possible to have particular interest on specific points. I also show you before that there are some specific web pages where it's possible to download for a specific point as a ASCII text file or Excel file values for time series for specific points of climate variables. So you will have for a specific point a long column with for instance, average temperature variable, and you can have this variable, and there are like some specific functions that allows you to integrate the aggregation, let's say an aggregation of different variables. I want to just give you an example maybe here. This is an example I downloaded here for instance from Climate Data Online, variables available for 4 or 5 stations in Tunisia for precipitation and average temperature. So there is a station, there is a name, so you have a date, and you see you have a daily time step. So starting from January 1st, 2000, it goes January 2nd, January 3rd, January 4th, January 5th. And then you have them here in 3 different columns for day, month, and year. And then you have precipitation and average temperature. So this is the average temperature for one day of the year for this station. Let me show you how pivot tables can be very effectively used. If I insert a pivot table here, it just highlights, and you can see a gray border that goes around all the data, and this is the window of all the data you want to analyze, and I say okay, I put it on new worksheet then, or can be also on the existing, but for the time being I say new worksheet. So this opens a new worksheet. So the new worksheet just generalize for the information for each of the columns. So we have here different columns. So you have station, it's the same station. Here you see Gabes, and then eventually you move to another station, Gafsa, and then I think you have Genduba, that you know probably better than me, and then Carthage. Of course, this is also an important Kalema station. So for instance, let's say you have a station which has a code and then the name of the station. I put here in the row. So row just tells me there are 5 stations in the data set. So let's say that I want to see now, I have them day by day, but I want them to see by month. I want an average by month of the values of average temperature. So I indicate the month. It's 1 to 12. See, I see here there are like month 1, 2, 3, 4. It just takes for the station guards the month 01, and then here, and there is nothing here. I just build the structure. In the rows I put name, and in the column I put months. What do I want to do now is to give information on a specific variable, so average temperature. What happened here now? Here it's just giving the sum of all the month values for the month of January for the station from the dataset, but rather than the sum, I want to have the average. So this is now the average of temperature, of average temperature for the month of January for one station, and I've had them for all the months for all the stations. So I have been very effective now. Try to imagine what could be the use to have structure for each data point, for each date, station, day, month, year, and the values. How easily you can structure information in this. You can have for all the 5 different stations, what is the values of average temperature for different months. But this can be done in many different ways. It's very flexible tool. So for instance, if I want for month, I want for different year. I have from 2000 to 2019 at this point, the value, the average temperature. And I can see how it changes the average temperature from year to year as the average within year 2000, 2001, 2002. I hope this can really help you to show you an elegant and easy and fast way also to elaborate data. Thank you again a lot.